so the equipment here is all contained in this box. We have two displays here. One displays the voltage, and one displays an amp meter. And this is in nanoamps. And what we can do is we have these 5 different LEDs, and they have the wavelength listed on them. And if we plug them in here, we can see that they turn on. So this is supplying a power to the apparatus. Now, what we want to do is we want to put this where this photocell is, and we want to be careful and make sure that the lights are turned off in this portion of the walk-in lab when you do this, because it's very sensitive to light. But if we take this off and put this light on, and it just goes in there, then we can see that there's current flowing, and that current is from electrons being knocked off inside this photocell. We have, it kind of looks like this, where we have a curved metal surface and an electron collector. And this is all in a vacuum so that we don't have effects of air that mess up with our measurements. But the light comes in to this curved metal surface and it knocks electrons off if it has enough energy. And then the electrons, basically there's a complicated circuit where we can measure how much current is from those electrons. And as we adjust the voltage that we are applying to the electrons to get them to move, we can measure how much kinetic energy they have. And so we have a coarse adjustment on the voltage here. As we see, as the voltage goes down, the current goes down. And then we also have a fine adjustment here. So this is smaller changes in the voltage. So I use the coarse one to get close to 0. Actually, I got a little bit past it. And then we can use the fine one to get all the way down there. And it kind of is delayed, so you have to be careful. But once you have this go to 0, and we want it right when it turns to 0 so we can check it. And this is the stop voltage that we want to measure. Okay, so as you can see, the first light that we've put in here is 505 nanometers. It's green light. And we just kind of adjusted this, as you saw. If we have the voltage here, we still have a little bit of current, and we want to get this to 0. So this is an incredibly small amount of current as it is. I mean, this is, we're looking at like 1 picoamp. So this is 505 nanometers of light, and our voltage is 0.471. So 0.471 volts gives us our K max, or sorry, our K stop, our V stop, from where we can find our K max by multiplying by the charge of the electron. And so that's for 505 nanometers. And so we can go ahead and we're just going to do this for all 5 of these different wavelengths. So I'm just picking them at random, but here's another one, 611 nanometers. We plug it in, and this is kind of an orangey light, orange reddish. Put that on. Okay, so we saw that this one has a lower cutoff voltage because we can see current now, but it's actually pretty close, so I'm going to go ahead and turn down the voltage. Okay, I'm at 0. I want to make sure I didn't overshoot it, so I'm just really slowly increasing the voltage. Okay, now we're back at 0.01. So if we go just a little bit down, there it is, the cutoff. Okay, so this is the voltage you're going to want to record for 611 nanometer light. It's 0.113. We have blue light now. This is 472 nanometers. Okay. Okay, and we can see this one has a bigger voltage. Okay. It's actually pretty close. And I just touched the fine adjustment knob and it went to 0. So actually I think we can go ahead and take that value. 0.622 I'd go with for 472 nanometer light. Now our next one is looks like yellow light, 588 nanometers. So we put that in there. And we're going to need to go down. So just this. And we start to drop to 0.001 on the current. I thought we were gonna, oh, there we go, went to 0. And here we are, it just fluctuated, so this is the cutoff. So 0.202 for 588 nanometer light. Okay, this is our last one. And we have green, kind of a fluorescent bright green light. And this one is 525 nanometers. Okay, we're gonna have to go up for this one. That actually might be good right there. Okay, we'll call that 0.417. 0.417 volts for 525 nanometer light.